Today I'm going to do something completely different. I'm going to break with tradition and I'm going to look at an old car radio. How old, you wonder? How does about 1948 sound? It's an old Ford Philco radio from an old car. It's going to be full of tubes and who knows what else is going to jump out. Anyway, this is just an evaluation. We're not going to do a full restore on this. The guy that owns it just wants to see whether we can make it work. So here's the old radio. And as I say, we're going to try and get this thing working today, and then he'll decide what he wants to do. This is an old Ford Philco battery-operated radio from, I believe this is 1948. It's when this one was made. It was from a 1948 Ford. My neighbor that collects old cars brought this to me to have a look at. I guess it went in the dash like this. I guess that's how it probably went in the dash. Let's see if we can get this thing working. I guess that's the volume control, and this is the tuning dial here. So an old beast like this, before anything gets hooked up to power, we're going to check this thing out and check out all the capacitors and stuff in it, because you know that this is going to have paper caps in it for sure, and they are going to be bad. Guaranteed to be bad. As I say, I'm not doing a full restoration on this unit today. I might change a couple caps in the coupling, interstage coupling, just to prevent tube failure, but this is more of a can we get this thing to produce any sound type of video today. So first things first, let's remove the screws from the cover and take a look inside. Antenna plugs in there, it looks like. I've never been in one of these old car radios. The most vintage one I worked on was from about the the early 60s or late 50s. I've worked on some of the ones from the late 50s into the early 60s, some of the old Philco radios back then. But nothing quite this old. Although a radio is a radio inside, right? And this is basically just an AM radio. There will be a couple of additional circuits in this thing that you would not find in a powered radio. Because it's running on 12 volts, we need to step the voltage up to a couple hundred volts for the plates. So there's going to be a step up converter in here. And of course, since this was before the day of transistors, it was a 100% mechanical setup. They used a device called a vibrator, hence the name, because it would actually vibrate when it was running. And what a vibrator did was changed the 12 volts DC to a pulsating 12 volts DC that was induced into the primary of the step-up transformer, which then provided the high voltage to the secondary. One more screw over here. And they would produce a buzzing sound when they operated, hence the name vibrator. Okay, this is just, oh look, there's a schematic in here. Well, there was a schematic. It's all coming apart. But there was a schematic inside of the radio. Might be able to piece that back together. Looks like this thing's been stored somewhere where it's been damp. Stinks. So this is the vibrator right over here, this piece. And if that's shot, the whole thing is shot. That's a critical component. Even listed right here, vibrator, right there. For those wondering how the vibrator works, this is a crude drawing. The transformer at the bottom is the high voltage transformer, and the component at the top is the vibrator. And basically how it works is it completes the circuit to ground coming in from the 12 volts. You'll see at the top of the circuit, 12 volts is fed into the coil. It completes through one half of the switch to ground, which energizes that electromagnet. This also energizes one half of the primary on the main transformer, as there's 12 volts also going in through the primary and being completed through the switch. Anyway, when the electromagnet in the vibrator energizes, it creates a magnetic field which pulls the iron bar or magnetic bar that's connected to a switch towards it. In that process, it breaks the connection to the normally closed contact at the bottom, and completes it to the normally open contact at the top, which takes the ground and it switches it from one side of the power transformer to the other. So now you've created an inverted magnetic field, which will create an induced magnetic field in the secondary. Since the switch completing the circuit to the induction coil in the vibrator has now been broken, the field collapses and the switch swings back the other way, breaking the circuit on the normally open contact and restoring the circuit on the normally closed contact, which then again reverses the magnetic field in the main power transformer to create another pulse of high voltage. And then it, of course, completes the switch for the vibrator again. It re-energizes the coil in the vibrator to complete the circuit. Electromagnet comes on, pulls the magnet back and forth. So that's what it's doing. It's just this pendulum swinging back and forth, which is making and breaking two contacts to switch the 12 volts DC, or in this case ground, back and forth on the power transformer. This radio is in sad shape. It looks like it's been wet. It probably has been. At least the tubes, I don't see any broken tubes in it. Getters are still looking okay, which is a good sign, because these tubes would be very hard to come by. The switch on the back, I guess that was a tone switch that's broken. Looks like it says tone. That switch is in pieces. This is using an electromagnetic speaker. Looks like big coil here that produces a magnetic field for the speaker. Again, I don't know what shape the rest of this is in. I got to pull the bottom off it, and we'll take a look at what's in the bottom of it as well, and then I'll assess it and decide what the next step is on this thing. There's the speaker, and it's got all these wonderful paper condensers in here. tuning capacitors behind this bulged out side of the cabinet. As for the plates for the tuning capacitor move, you can see it here. You can see the top of it there. It's got a dial string that goes around and turns it. This is kind of sticking, but it does move. First thing I want to do on this is I want to see whether the vibrator even works. So we'll connect up power to it. I've got my 12 volt power supply here, and connect up power to the radio. I believe it's a 12 volt one. Don't know how it even turns on. Is that the switch there? Okay, that should be the switch, so that should be on, and it is not doing anything. We should hear the vibrator humming, and we don't. So that's obstacle number one before we even get into any of the replacing caps on this thing. I want to make sure that we can actually power it up, and we should hear it's not drawing any current whatsoever, but we should hear the vibrator come on, because that's how they work. Make sure that my power supply is actually putting out 10 amps, so it should be getting power now. And there is nothing. So first, we'll just check to see if there's any power getting to the vibrator. As there should be 12 volts getting to one of the terminals on this. And if there is none, so I don't see any power getting to the vibrator. That would explain why it's not working. Could be a bad switch. Would be the next thing to check is the switch. So the switch is over on the side here. Let's take out this screw. Okay, yeah, oh, the switch is shot. Yeah, you can see it. The switch itself is burned. If we look at a different angle, see this? The switch itself is all burned up. This capacitor here is probably also bad. This is just a filter to filter out the alternator noise. So what I can do on this is we can just put power directly to here and see whether the vibrator starts up on this, because that's the first thing, and it does. We got juice. Are we gonna get sound? Incredible, huh? Tubes are lighting up. I can see them. Oh my God, I hear sound. I hear something. Where's an antenna? This thing might even pick something up. You know that?
Connected to Scott Better.
This is a Bloomberg Pursuits look at Nitro. Amid a pandemic and protests, global warming marches on. And Dune Road, 0.9 miles rear.
Not much of an antenna. It actually picks something up here.
But that provision runs out in 2020.
It's got presets as well as manual tuning. Trying to figure out which one's which.
A long-term acceptance of remote work and strict lockdowns have added fuel to shift from... Claim ownership.
Oh, there we go. My test transmitter. So this bloody thing works. Incredible. Incredible. Just a switch was shot on it. I mean, now that we know that it's going to go somewhere, I can, we'll take the power off it now. I don't want to. This wire is hot. How much? Holy smoke, this thing's drawing 10 amps. This thing's drawing the limit. Look at this, taking my power supply down to 9 volts. I don't know how much power this thing draws, but it certainly draws more than 10 amps. It's got the wires hot. Like, this is hot to the touch. These wires, look at, they're melting. It's melting the wires to my power supply. But hey, this thing actually puts out sound. So now we can concentrate on changing out the paper condensers on this thing and restore it to its full glory. Well, as good as we're going to restore it. I'm not going to do any cosmetic work on it, but I will change out the paper condensers. This is going to be a tough call, this one, because the switch itself is shot, and good luck trying to find this. It's actually gear driven from this. There's a little gear in there that turns the volume control in the switch. So that is going to be a tough call to get that. But the switch can be bypassed so that it runs constantly, and in the car he'd have to put an external switch just to shut the power off externally. That's not a big deal. But obviously this thing draws so much current. That's why the switch is burned up. This thing probably draws 15 amps or more. These things were beasts. And that's why back in the day when tube radios were used in cars, that people had a dead battery after only a few minutes of operation, because this thing would draw a lot of power and would run a battery down pretty quick. So now we know the radio works. What I need to do is change the, not all these paper caps are ones that are going to cause a problem, but the ones that provide coupling from the plate of one circuit into either a transformer or into the grid of another circuit. Those are the ones that are the most problematic, just due to the fact that if they go electrically leaky, which there's a good chance that they are or heading that way, when they go electrically leaky, they can cause overcurrent and overbias a tube, and cause a tube to draw too much current and go out, and it came with transformers, overload transformers, etc. So we want to try and replace the ones that are more likely to be the ones at fault for problems. Just going to go through and we're going to change out these paper caps to some new Mylar type caps, and then we'll leave it at that for this restoration. So I don't know how far the guy wants to go that owns this. He wants to get it running. Obviously, it's not going to be a daily driver. It's going to go into his old car and possibly get used when he drives his old car in parades and stuff. It's not like he drives the old car every day. He might put this thing on the road for a month out of the year, if that. It's mainly just to show off and show in parades and say that cosmetically it's not in great shape, but that can also be restored. So first, let's take a look at some of these caps, and I'm just going to go and I've got my replacements here, and we'll see what I've got and what we can change on this. Try and get this thing restored as inexpensively as possible at this point. So here's an example of a capacitor that's gone leaky. So this is mega ohms. It's charging up very slowly, but it should go to infinite. And this is not that big a condenser. It should be infinite by now. Capacitance wise, this is like a 0.6 microfarad. So that should have gone to infinite resistance very quickly, but because the paper inside is breaking down and becoming acidic, it's now starting to become conductive, and that causes the DC voltage that this is intended to block to start leaking through. So that's why we have to go and change these paper and capacitors like this that have gone electrically leaky. Now I don't have a breakdown tester, so I can't tell what voltage it's breaking down at, because I don't do enough work on tube radios. I have never bothered to invest in a breakdown tester. So I changed out this one here. I got a few more to change in here. I'm going to do the critical ones that are critical for coupling, the different stages, working off of this bad excuse of a schematic, as I'm not able to find a proper schematic online for this radio. But I'm just going to go through and change the ones that are the most critical that I can find, and I'm going to leave it at that, just because I don't know how far the owner of this wants to go, whether he just wants to make it work to produce music, or whether he wants to go for a full restoration. He was more interested to see whether I could get it producing sound, which I've done now. So now I say I'm just going to do a couple more of these caps, and then we'll take it from there. And then at that point, if he wants to go further, then we'll come back and spend some more time on it. So let's change some capacitors. Okay, this is another one. This is the audio output, the coupling cap between the audio and the output. And as you can see, this one here is also has a little bit of leakage. 20 mega ohms approximately on this one. That's the resistance. It's a 0.2 microfarad. So that should be like well over 30 mega ohms. Should be into the over range here. But change that one as well. I'm going to get a couple more of them in here, and then I'm going to just call this a day for now, just because I change them all out. But I just want to know how far the guy wants to go on getting this. So I'm just going to do the ones that I think are the ones that are most critical as far as protecting tubes go. Right, some of the bypass caps that go to ground aren't so critical because they're really not going to cause a failure of a transformer or a tube as a result of it going to electrically leakage. It's the ones that couple between the tubes and the IF stages and the transformers and stuff. Those are the ones that are most critical. So I'm just going to put this back together for now. I've changed out 4 of the caps in here. We're going to set it back together, and then I get a hold of the guy that owns it, and we'll bypass the switch so that it'll operate. The capacitors I've changed on it are the ones that are coupling between different stages that are used as blocking. So basically, the big one, of course, is the blocking between the plate of the diode tube and the audio output grid, because that's the plate, this one here and this one. I think those are the ones. No, this one and this one. Because the DC voltage coming off of the diode plate going into the grid will cause the tube to go into conduction and draw a lot of excess current, which of course will destroy the tube. Many of the other caps in here are just bypass caps, which are like grounding the cathode, bypassing the cathode with a cathode resistor. So they're not as critical as far as causing a catastrophic failure on the unit as the ones that I changed on it. This is kind of more like a Shango style video where he explores some old radio or old TV to see what needs to be done, but leaves it up to the owner of it to decide where to proceed. Like all these wires could easily be cut off and replaced too, because the insulation on them is pretty ratty, which is to be expected of all these old dinosaurs from the 1940s and 1950s. The very fact that this thing actually even works at all, I was quite surprised that this thing actually powers up. Especially since it looks like it's been wet. It's all rusting. I guess the schematic should go probably back inside it so that it doesn't get lost. It was in the front here. We'll just set it right in there next to the tuner. Okay, there it is, back together. Well, I love this preset tuning. Okay, I better shut this off before I burn out my, not so much my power supply, but melt my lead. It's getting pretty warm. Anyway, that's the unit's all back together. It's functional. Now I leave it in the owner's capable hands as to what he wants to do. I notice that the dial is also off here. It's not the tuner is off, because when I run this all the way to the top, it stops at around 1400. Like don't go all the way down, it goes down below 55. So it's actually the dial position is off, not the tuning capacitor, but the dial position is off on this. I don't even know how they set the presets on this thing. I guess there's a bunch of slugs in here that you preset. I guess that the unit is taken apart and the presets are preset by adjusting slugs. So a radio like this would have been, when it was installed in a car, it would have been preset to 5 of the most common local AM stations that were on the air at the time. It would have been preset to all the local stations, and then you had the VFO where you could tune it around. And I guess there was maybe a sticker or something on here that told you which one, what they were preset for. I don't know. Anyway, it's a push button. It changes sequentially. It just has a switch inside, and it just changes between the 5 presets and the variable tuner. Anyway, that's this old antique. I think he said it was a 1948. It's either a 48 or 51. I think it was a 48. He said it came out of. Anyway, that's a quick look at this unit. Thanks for watching.